Welcome to this video about FeDeV, a feature and feature dependency visualization tool developed by ScopeSet. The main purpose of FeDeV is the visualization and exploration of extraction results. This information is provided by external tools like KernelHaven and VEXA. FeDeV also provides an interface to get detailed information of selected elements like the name and the feature location. We use this interface to build an integration with Eclipse Capra, where additional trace links, for example to requirements or issue trackers, can be set up. The visualization of extraction results in FeDeV is done in three views: a tree view, a table view, and a graph view. The tree view is typically used to show a file system or to show the architecture of submodules. The table view lists information for features, feature dependencies, and submodules in tables, similar to Excel. The graph view shows nodes and edges and helps to explore the extraction results stepwise. In addition, predefined filters and an advanced search functionality is provided. The feature visualization in the graph view provides several additional information. The node symbol for features shows the feature name, the constraint for this feature, and the amount of incoming and outgoing dependencies. We use color coding to visualize dependency states. In blue, we have root nodes. These are independent features with no outlinks. Purple shows intermediate nodes. They are referenced by others and have dependencies to other features as well. Green are leaf nodes, with dependencies to other features, but they are not referenced by other features at all. We also use color coding for feature dependencies. Green shows a single required dependency, pointing out that the selection of both connected features is a valid configuration. In contrast, orange points out a conflicting dependency. Both features are not allowed in the configuration. Black shows multiple required dependencies, and red cycles between features. Let's have a look at the tool itself. In this demonstration of FeDeV, we use data provided by KernelHaven for the Linux kernel. If we look at the statistics, we see that we are talking about a big system with 12,000 features and 40,000 feature dependencies. The features are organized in 300 submodules. The tree view is showing the submodules of the Linux kernel. We can simply click on a single submodule to see the contained features. More detailed information about features are shown in the feature table, showing the name of the feature, in and out links, and the constraint. Additional tables provide more information, for example, about the dependencies and the submodules. In the graph, we see features and feature dependencies using the color coding as explained in the slides before. The tree views are synchronized on the fly. A selected feature in the table is highlighted in the graph and the tree view. If we select a feature in the graph, it is immediately selected in the tree and the table as well. We will now show you how to explore the data for a single feature. Let's assume that we are interested in a feature named config ATH10K. Therefore, we search for this feature. As a result, we see this feature as a node in the feature dependency graph, showing its name and the constraint. The complete constraint of the feature can be visualized in the graph by simply moving the mouse over the feature symbol. We also see that this feature has 14 inlinks and 3 outlinks. We can now stepwise explore the data to see more features. To see additional required features, we can add the outlinks to this graph. We now see the 3 outlinks of config ATH10K as well as all outlinks for related features up to the root node. We can also do the same for the inlinks. As you can see, such graphs can become complex quite easily and therefore difficult to read. We can try a different layout to see if the graph is easier to read then. Or we can use filters to reduce complexity. If we are not interested in cycles, we can use a predefined filter to remove them from the graph. We can also collapse features into submodules. This will also reduce the complexity of the graph. Features are organized in submodules, where one feature is contained in at most one submodule. But for example, some features of the Linux kernel are not contained in any submodule. The picture shows the collapsed and expanded view of submodules. In the expanded view, the features contained by a submodule are shown within a dotted rectangle. Dependencies between submodules are defined by feature dependencies. In this example, we see that block depends on XFS. This is because a feature contained in block depends on a feature in XFS. For submodules, we provide 2 types of graphs, depending on the context. The architecture context shows all direct incoming and outgoing dependencies of a submodule. There's another context for all incoming or outgoing dependencies. This graph shows all direct and indirect dependent submodules of one selected submodule. To avoid an overload of dependencies in the graph, already discovered dependencies are skipped. We can now collapse the remaining features into submodules as well. As explained in the slides before, dependencies between submodules are derived from the contained features. Submodules can be expanded on demand. The contained features are shown in a dotted rectangle. If we want to further explore a single submodule, we can dive into it by double-clicking the green arrow. The resulting graph shows just the features of the submodule of interest. Finally, we can have a look at the architecture graph for submodules. All submodules we discovered so far show up in this graph as well. If we are now interested in the architectural context of net/wireless, we just select Show Submodule Architecture Context for it. This shows all dependencies of net/wireless in the graph. FeDeV is developed and maintained by ScopeSet. We received strong support by the University of Hildesheim, the FZI, and the University of Gothenburg. More details about the partner products, KernelHaven, VEXA, and Eclipse Capra are shown in extra videos. For more information on FeDeV, feel free to contact Michael Wenkel or Felix Suda at ScopeSet. You can also use this link to download the latest version of FeDeV, as well as some documentation. Thank you for watching this video.